Hello students, in this video we are going to see an example number 7 in the normal and tangential components. Okay, read the statement. An automobile is originally at rest at s is equal to 0. See in the figure, automobile is starting from point O. So when s is equal to 0, the velocity, the speed of the automobile is 0. It starts from rest. It then starts to increase its speed according to the equation v dot is equal to 0.015 t square meter per second square. Now what is this v dot? The first derivative of a with respect to t, that is dv by dt, nothing but tangential component of acceleration. So at is 0.015 t square meter per second square. Okay. So it is not constant tangential component of acceleration. It is the function of time t, point to be noted. Determine the magnitude of its acceleration when t is equal to 18 seconds. S, v and t are in meters, meters per second and seconds respectively. Okay. Say automobile is starting from point O with 0 speed and then it accelerates as a function of t as per this expression, and from 0 to a it is moving along a straight line, so it is having rectilinear motion. From a to b, see AB is a quarter circle, so the automobile will move along a curved path from A to B. Now we have to find out the acceleration when t is equal to 18 seconds. So here t is equal to 0. After 18 seconds, first you have to find out the position of automobile, whether it is in the range OA or in the range AB. If it is between O and A, it is having rectilinear motion, right? If it is between A and B, it is moving along a curve. Then the acceleration will have the tangential and the normal components, from which you can find out the resultant acceleration. Is it clear? So it is given that originally it is at rest, so initial speed is 0, s is equal to 0 when t is equal to 0. Then the speed is increasing according to the equation v dot 0.015 t square. So you have to find out the magnitude of acceleration when t is equal to 18 seconds. Right? So starting with the given equation, v dot is nothing but dv by dt is equal to 0.015 t square. Say equation 1. This is also the tangential component of acceleration. Now dv is equal to 0.015 t square into dt. Now integrating this equation, we get v is equal to 0.015 into t cube by 3 plus c1. c1 is the constant of integration. We can find out the constant of integration from the initial condition that at t is equal to 0, v is equal to 0. So putting t is equal to 0, v is equal to 0, we get c1 is equal to 0. So the speed of the particle is given by v is equal to 0.005 t cube. Say this is equation 2. Is it clear? Okay. Now at t is equal to 18 seconds, you have to find out the position. So now v is equal to ds by dt, right? V is equal to ds by dt, which is equal to 0.005 t cube. Now ds is equal to 0.005 t cube into dt. Now integrating on both sides. Now to find out the position, we can use definite integral here, because we know the limits. When t is equal to 0, s is equal to 0. So when t is 0, we have s is 0. When t is equal to 18 seconds, we have to find out the distance, that is s. So integrating this, we have s between the limits 0 to s is equal to 0.005 t raised to 4 by 4 between the limits 0 to 18. So solving this, you will get s is equal to yes 131.22 meters. So this is the distance traveled by the automobile at t is equal to 18 seconds. See, from 0 to 8 is 90 meters. So it is 131.22. That means it is in the range AB. So the automobile is having curvilinear motion, right? Then we have to calculate AT and AN. So from equation 1, at t is equal to 18 seconds, from equation 1 we get AT, that is tangential component, 0.015 into t square. And from equation 2 we get the speed of the automobile, that is 0.005 into 18 cube, right? So do the calculations. So we have AT 4.86 meter per second square and V is 29.16 meters per second. So this is the speed of the particle at t is equal to 18, from which we can find out the normal component of acceleration. An is equal to v square by rho. V is 29.16 square, and what is rho? Radius of curvature of the path. It is given 72 meters. 72. So the normal component of acceleration is 11.81 meter per second square. Now what is the resultant acceleration? The magnitude of acceleration, total acceleration, is equal to square root of AT square plus AN square. So putting the values, 4.86 square plus 11.81 square root. This will be 12.77 meters per second square. So it is the magnitude of its acceleration when t is equal to 18 seconds. Understood? Thank you.